In today's video, we are going on a journey to the edge of the observable universe. Hold on to your spacesuits because things are going to get very big very quickly. Let's go. Here we are in our cosmic neighborhood, the solar system. We've got the sun here, which is a pretty average star, and we have 8 planets orbiting around it, including Earth, which is not very special at all. If you want to get to the next star over, we need to travel 4.2 light years. That's how far it is from us to Alpha Centauri. It takes light 4.2 years to make that journey. So if we want to get there, it would take a spaceship over 4.2 years as well, assuming we could travel at the speed of light. But for now, the fastest spacecraft we have ever built can only reach about 1% of the speed of light. After 4.2 years of traveling at almost the speed of light, we arrive at Alpha Centauri. This is actually a triple star system, but let's just zoom past these stars and focus on the next one. The next star up is Proxima Centauri. There's a bit more space between this one and Alpha Centauri. It's 5.3 light years. Now we're starting to enter the interstellar medium. These tiny little dots are stars. They look so small because they are incredibly distant. Just remember, these stars are huge balls of burning plasma. They're massive. They just look small because they are so incredibly far away. Traveling at the speed of light, it would take us 16.3 light years to reach the next star. But luckily, we don't have to travel that far because there's a cluster of stars right in front of us. It's the Pleiades, or the Seven Sisters star cluster. Now we're entering a region of space with a lot more stars. All of these stars are relatively close to us. But the really cool thing about them is that they are all orbiting around something. They're orbiting around a giant ball of mostly dead stars called a globular cluster. Now we're entering the thick disk of the Milky Way. Here's another globular cluster. These things are basically like the janitors of the galaxy. No one knows exactly what they do, but we know that they exist in huge numbers and they keep everything clean. Okay, that was a terrible joke. Moving on. We're relieving the disk of the galaxy behind and entering the supercluster of galaxies known as the local group. Here's a smaller cluster within the local group called the Laniakea supercluster. We're going to be flying straight through the center of this supercluster. Whoa, are you seeing what I'm seeing? There are galaxies everywhere. Every single one of those dots is a galaxy, and those galaxies are made up of billions upon billions of stars. If we were to leave the local group and fly in a straight line for 100 million light years, we would end up in the constellation of Cancer. Now we're really flying. We're passing by galaxy clusters and groups. We're even passing by other superclusters like the Virgo supercluster. There's the Shapley supercluster. We're going so fast that these superclusters are whizzing by like cars on a highway. After about 10 billion years of traveling at the speed of light, we arrive at the edge of the observable universe. Remember at the beginning of this video when I said that if we wanted to reach Alpha Centauri, it took light 4.2 years because that's how far it is. Well, the distance from our galaxy to the edge of the observable universe is also 4.2 years. It's the same distance. The only difference is that it's in a different direction. Now, I know what you're thinking. If light can travel 4.2 years in one direction, then why can't it travel 4.2 years in the opposite direction? Why are we stuck in this galaxy? Can't we go any further? Unfortunately, the answer is yes. We can't go any further. We are at the edge of everything. There is literally nothing out there. Oh wait, what's that? What lies beyond the observable universe? We don't know. It's unobservable. That's why it's called the observable universe. It's what we can observe. We can't see what lies beyond because light hasn't had enough time to reach us. If light was faster, then we would be able to see further. But since it's not, we're stuck. For now, the furthest we can see is 4.2 years in any given direction. So that's it for today's grand tour. I hope you enjoyed it. If you did, please hit that thumbs up button. Thanks for watching.